Every day, billions of people rely on one of the oldest processed foods known to humanity, bread. It's so simple, yet in the modern factory, it becomes an exercise in staggering industrial perfection. We aren't talking about a small bakery, we're talking about a facility that produces hundreds of thousands of perfect loaves every single day. This is the Built Bazaar guide to the full-scale manufacturing of commercial bread. We are tracing this process from the raw, milled grain to the final, perfectly packaged loaf. Along the way, we'll encounter massive silos, dizzying automation, and a level of precision engineering that turns simple ingredients into a global food staple with zero room for error. Prepare to see how the world's most basic food is made on a bizarre, hyper-efficient industrial scale. Phase 1. Mixing and dough preparation. The journey begins not on the factory floor, but high above it in the colossal storage silos. Tons of high-protein wheat flour are delivered daily, meticulously categorized and stored. The purity of the flour is critical. Automated systems continuously sample and test the batches to ensure they meet the specific protein and moisture standards required for the end product. Any variance in the raw material can completely derail the entire production run. From these silos, the ingredients are summoned via a vacuum transport system. This is a closed-loop environment, ensuring absolutely no contamination. The next critical step is the mix. We're not using measuring cups here. We're using highly calibrated electronic scales and flow meters. The recipe is programmed down to the nearest gram, accounting for flour, water, yeast, salt, and any necessary dough conditioners, those essential ingredients that give the bread its shelf life and soft texture. The water, often temperature controlled to within a fraction of a degree, is a key variable, dictating the dough's final consistency and the rate of yeast activation. Once the ingredients are in the colossal industrial mixers, the magic of mechanization begins. These aren't just stirring, they are developing the dough. The intense mechanical action builds the gluten network, the protein structure that allows the dough to hold the gas produced by the yeast. If the dough is undermixed, it won't rise properly. If it's overmixed, the gluten network collapses. It's a precise balancing act, managed entirely by computer-controlled cycles. After the initial mixing cycle, the dough is not immediately processed. It needs to rest. This is the first fermentation, or bulk proofing. The dough is transferred to a trough where it rests for an allocated period. This allows the yeast to begin consuming the sugars, producing carbon dioxide and developing the complex flavor profile. This rest is crucial for texture. It relaxes the gluten, making the dough easier to handle in the subsequent automated stages. 3. Phase 2. Shaping and proofing. Once the bulk proof is complete, the dough is ready to be portioned. The first machine it encounters is the dough divider. This machine is an engineering marvel. The mass of dough is forced through calibrated openings and cut with absolute surgical precision. Every piece leaving this machine must be exactly the same weight. Why is this detail so critical? Because every subsequent process, proofing, baking time, and slicing, is calibrated to that exact weight. Inconsistent weights lead to inconsistent baking and final product quality. Following the division, the dough pieces are routed to the rounder. This machine gently rolls the pieces into perfect spheres. This step serves two purposes. It seals the edges of the cut dough and helps re-establish a smooth surface tension, preparing it for the next rest. We now enter the intermediate proof, often called the overhead proofer. These are slow-moving trays that carry the dough balls through a warm, humid chamber for about 6 to 8 minutes. This rest is crucial. The aggressive cutting and rounding processes have tightened the gluten, making the dough stiff. The intermediate proof allows the dough to relax, ensuring that the molder, the next machine, can shape the dough without tearing it. The molder is the machine that dictates the final loaf shape. The dough pieces are gently flattened, degassed, to control the final rise, and then rolled tightly into a cylinder. The cylinder must be uniform in thickness and length. Immediately after, the perfectly molded dough is released, or dropped, directly into its dedicated baking pan. This process happens at lightning speed, with pans being filled in rapid succession along the conveyor line. Phase 3. Baking and cooling. Now the bread enters the final, most important proofing chamber. The pans are automatically stacked and moved into the final proofer. This environment is strictly controlled. High heat, high humidity, usually around 100 degrees Fahrenheit and 85% humidity. This is where the magic of the yeast explosion happens. The loaves swell dramatically, almost doubling in volume, and achieve the characteristic, soft texture expected of commercial bread. Any flaw in the earlier stages will manifest here, resulting in a misshapen loaf. The final proofing can take anywhere from 45 to 60 minutes. The moment of truth arrives as the pans exit the proofer and immediately finally enter the colossal tunnel oven. These ovens can stretch hundreds of feet in length. The baking process is zonal. The temperature is highest at the entrance to ensure a quick, powerful spring in the dough, and then gradually decreases to cook the interior evenly and develop the crust color without burning. The baking time is exact, perhaps 18 minutes. No more, no less. A single minute too long results in dry bread. A minute too short results in doughy bread. Once the time is up, the loaves emerge, golden brown and perfectly baked. The immediate next step is deepening. Using a vacuum system or gentle mechanical pushers, the baked loaves are instantly ejected from their pans. The now empty pans are whisked away to be cleaned and readied for the next cycle, while the hot loaves are ushered onto the most bizarre feature of the entire factory, the spiral cooler. This giant, multi-story structure is simply an automated path for the bread to cool naturally. The loaves must cool completely to about 95 degrees Fahrenheit. Attempting to slice or package a hot loaf would lead to tearing, steam buildup, and spoilage. The cooling process ensures structural integrity and extends shelf life. Conclusion: slicing and packaging. After a cooling process that can take over an hour, the loaves are finally ready for their final transformation. They are delivered to the slicing station. These machines operate with incredible, almost terrifying speed. Using thin, surgical-grade blades or oscillating wires, they can slice hundreds of loaves per minute, producing uniform slices that are critical for consumer appeal. The speed is so high the blades often appear as a blur on the factory floor. Immediately following the slicing, the bread is automatically pushed into its plastic bag in the bagging machine. This is where the distinctive plastic bread clip or twist tie is applied, a seemingly trivial item that is actually the final seal against environmental spoilage. From the bagging machine, the bread moves into the logistics phase. Cases are automatically packed, sealed, and prepared for shipping. This final automation ensures that the product moves from the oven to the loading dock in the shortest time possible, maximizing freshness for the consumer. The complexity of this operation is stunning. It's an exercise in maximizing throughput while maintaining perfect quality control. Every sensor, conveyor belt, and machine is calibrated to work in continuous harmony. The next time you grab a loaf of bread, remember the silent, bizarre, and perfectly engineered journey it took from a field of wheat to your table. It's proof that sometimes, the most basic items require the most advanced technology. If you enjoyed this deep dive into industrial manufacturing, hit that like button and subscribe to Built Bazaar for more looks inside the factories that shape our world.